Hi, everybody. Thanks for coming.
Hi.
This is the last session of the entire conference, I think, so we appreciate you hanging in there with us.
Yes, we'll try to keep it lively so you don't fall asleep. So today we're going to talk about the truth about your assets. So if you're a 3D artist or you're just getting started, you can see the current pipeline that we both like to use. Or if you don't do assets but you manage a team where you have artists and you're not so sure what their process is, you'll get to learn about that today.
So this is who we are. I'm Suzanne Leibrick. I am a virtual emerged reality experience designer at Intel. I'm also co-founder of the AR/VR Academy, a nonprofit that teaches VR development to underrepresented groups in tech. I'm a full stack VR artist and designer, so I do lots of different art and design things. And if you want to follow me on Twitter or tweet to us during this session, my handle is inanimute.
And I am Jazmin Cano. I work at Fidelity, and Fidelity is an open source social VR platform that allows people to create, design, and explore virtual worlds. And I've been working there for over a year now, creating so many virtual worlds. And I'll show some pictures with you in a bit. But before that, I was working in games, and I started working on VR projects at several startups since 2013. So things have changed, and I have learned a lot, so I'm excited to share with you what I have learned.
All right, let's get going.
So these are some examples of the most recent work that I've done. Working in VR can be very hard because you have to keep your content optimized so that your performance is good and no one gets sick. The worst is when you do something and you create a project and you put on someone's face and like, oh my God, I feel terrible because you're at 45 frames or something. So here are some of the ones that I've worked on. And these are all online in a virtual world that I hope you can hang out in with me. But these are some examples. So I've designed...
This is my favorite one.
Thanks. I've designed experiences that range from stylized, unreal stuff like this. This is Sinaparo in Mexico, which is where my family grew up. So I decided to recreate it in a more fun way that you can't experience in real life. And other environments rely more on realistic textures, where I will be chatting about PBR, because those are also fun too. So this is some 3D software that we use, and we've also listed others that are quite popular. What's your favorite 3D modeling software?
It's definitely got to be Maya.
Maya's mine too. There's also 3ds Max, ZBrush for more of a sculpting technique. There's also Blender, which is free and open source, and texturing.
Photoshop, definitely.
Photoshop?
Yeah.
For me, I lean more towards Substance Painter. I will be showing a bit more of that. That one helps me create all the maps I need for PBR. And GIMP, I hear, is really similar to Photoshop, and it is also free. So I will be checking that one out.
Okay. And I really like 3D Coat for a step we're going to talk about in a little bit, which is UV unwrapping. It's a really solid program if you don't really like unwrapping UVs. Highly recommend it. And we put Oculus Medium there because obviously that's a brand new way you can use VR to sculpt stuff for VR.
Yeah. So this is what we're doing today. You want to explain what we're doing?
Yeah, we're going to do the entire art pipeline in under an hour. So we're going to skip a few things and do here's what we made earlier a couple times. So a little bit like a cooking show, but we're going to go from a concept to model to UV layout, texturing, rigging, animation, and export. And that's actually the order that you would do those steps. There are reasons why you would want to do UV layout before rigging, for example. So this is generally a pretty solid standard pipeline for anything you're going to animate. Okay.
So let's start. Where do you begin? So most artists start with concept art, researching what they want to build or researching what the project is and what it should look like. And prototyping. Prototyping is important. A way you can do it with 3D modeling is by doing something called white boxing or gray boxing, which is throwing cubes together in the space, checking the scale, making sure that this is what you want to go for. So that's why I wrote box modeling. Kind of call them VR sketches nowadays because you got to do it quick, put on the headset, see if it actually looks right, if the scale is good. You wouldn't believe how weird a door can look in VR if you are doing it for the first time and you don't know what the scale should be. You would model one and the doorknob could be tiny or huge, or your face is at the top of the door, so it's always good to prototype your models.
Yeah, checking scale is super important as quickly as you can.
So concept art, when we first talked about doing this, we thought, what is a good way to combine our skills? I do more environment modeling, more hard surface. Avatars are something that I don't have much practice with, but I like to say that Suzanne is the rigging and animation expert, so I thought a robot was close enough to not being totally human, but something more boxy, and something that she can animate in a really cool way. So, like I said, always start with concept art, so while chatting, we decided to just sketch a random little robot, use that to start with, and the next step is to just model and UV it. Once you've sketched it, you've built the basic shape of it, and I'll have some pictures here. Now, before I jump into actual photos of the robot, I wanted to tell you about some things you should check. So, a lot of the times when you're getting started, or let's say you're not an artist, but you have content that you bought somewhere and you're putting it in your engine and it kind of looks weird, or it's not looking right, or there's something missing or wonky, always check the following. So first, your budget. See how many polys you're actually rendering. If you have like 5 million, that is insane.
That's way too many. Yeah.
That's bad. So it's good to check how many. Depending on what software you use, you can check exactly how many triangles are on the model.
Yeah, and different platforms are obviously going to support different numbers of polys. So for mobile VR, 20,000 polygons per scene is a number that's fairly solid. And then for like desktop VR, you might have 100,000 to play with. Again, a lot depends on the experience. There's other things that can be done to optimize, but those are sort of like benchmark numbers.
Mm-hmm. And if you find that a model that you have has way too many polys and you really want to use it, you don't want to rebuild anything else, look at the edge loop. So in the first cube that you see, the most simple cube possible, next to it the edges have been beveled. And beveled is what you do when you add more edge loops to the curve so that it's got a more softer organic shape. Now the third cube to the right of that, you can see the top part is indented. It shows that every vertex on the top is needed. If you were to delete one, instead of being a soft curve, it would have a sharp angle, which you may see sometimes, especially in the low poly style. They do that on purpose. You can see every edge loop and every corner, and that's a really nice style. But on that same third cube, you can see on the bottom that I have pinched the edge loops to go to the corners. If they were to continue down, I think you'd have maybe 10 triangles, and now there are 6? Mm-hmm. Yes. So deleting your edge loops or merging your verts is always going to help in the end, because you can start with something that has 2,000 triangles and end up with 600. The next part, n-gons.
What's an n-gon?
So an n-gon, I don't even know how the term was invented, but it really means just don't have something that has more than 4 verts, 2 triangles, so you can have a triangle, or a square, because a square cut in half is 2 triangles. If you have a face on a model that has 6 dots and no edge loops connecting them, then that's going to cause problems. Sometimes they don't get rendered, or sometimes the collision won't actually appear on it, so you may be falling through something that doesn't.
Your rigger will also hate you.
The rig will hate you.
Because what happens if you have an n-gon is it will bend in really unpredictable ways when you're trying to make something that moves really super nicely. And yeah, so no, avoid them.
It's just bad.
Yes.
A lot of these tools do have a cleanup option, so whatever you use, look for documentation. There's a bunch online, and a cleanup tool will find those and just slice them up for you like pizza. So, coplanar faces. If you ever see a game where things are flickering, or you're in an experience and you see a table that has some flashing color on it, it might be that there's actually 2 planes at the same exact space, and the engine doesn't know which one to render first. So it's like this one, this one, this one, this one, and it's just like flickering. That's also not really fun to see. Just make sure you clean it up.
Yeah, so it's known as like Z-fighting.
Yeah,
it's another term for it. But that's really what it is when there are 2 planes together. Like a really common way for that to happen is if you've taken a model that you built in like AutoCAD or some other like CAD software, and then you want to bring it into a game engine. That's a really common thing that those pieces of software do, is they put 2 planes together.
Yeah, and the last one on top of that, sometimes I'll have emails saying, for some reason this part of my mesh is just not appearing, but it shows up in Blender or Maya and I know it's there. There's a thing where the plane has something called a face normal, and it has a direction it's pointing in. Let's say that this bottle here is a model, and maybe this row of the cylinder, all the face normals of those planes are facing in. You won't be able to render from the inside out, but you can render everything on the outside. So this will look like it's gone. It's missing transparent. It's really not. You just have to flip your normals, or you can make it double-sided, so you can select a model. Extrude it is a term for giving it volume. That way you don't have any flat planes that may look like they disappeared and ran away.
Yeah, every polygon is one-sided unless you decide to make it a two-sided object. So it's worth thinking about. But then most of the time you're not going to want to do that, because if I did want to model, say, a bottle of some kind, I don't really want the engine to have to work for all those extra faces. It's just performance hit that we don't really need.
Yeah, if we were in VR right now, I probably wouldn't even model this back half, because you don't need to see what's on this side, so we have better performance and we all feel better when we see it.
Yeah, that's a really good way to optimize too. If objects are really far distance from the camera, you don't necessarily need to see behind them. So why would you model the whole thing? You know, if I've got houses in the background, I might not want to model every door and every window when I could just use a texture to do the same thing, because it's far enough away from the user that they're not going to be able to perceive the difference, and I can use just like 1 or 2 polygons for an entire house instead of like hundreds potentially.
Yeah, that saves a lot of time, and if maybe you are new to managing a project and you see that your artist has not bothered to put any decorations on the back of something that's not going to be seen, it might be for a good reason, so there's no need to scold them by saying, why didn't you put a window back here? Don't be that person. And last thing I want to mention before we move on is that this cleanup does take a lot of time. So when folks get projects where they need to do something really quickly, that can be quite stressful, because modeling can be done and texturing can be done, but there still needs to be the cleanup and optimization. So these are just a group of the things that need to be checked out before actually put in an engine.
All right.
Optimization, so important. So monitors usually run at 60 hertz. They can range, but your HMDs run at 90, which is why you have to have your content running at 90 frames a second, or else you'll get a headache or you'll feel weird and you will just be so upset with whoever made the project, and you don't want people to be upset when they see your work. So when you're modeling, always pick up your HMD and test it. Make sure that everything's running fine. Sometimes accidents happen and you may have exported the wrong file, and all of a sudden you're at 30 frames. And that's easily solvable by just testing it and then seeing what the problem was and fixing it. So always check. Okay, so back to the pipeline. Now that we had our robot sketch, it was time to model. And since it was a 2-person team this time, I did the basic blocking, the white box that I mentioned, the shapes, making sure it looked okay. And I said, hey, Suzanne, is this okay? I drew blue lines where I picture the rig would go. Is this cool?
And I said, yes. I said, that's great. Go ahead.
So I went ahead and I added some nice bits and a bow and a backpack and a cute little heart, because it does have feelings, even though it is a 3D robot. Now, after you're done modeling, the important part to do after is UV and wrapping. Now, when you first open up your UV editor, you will see spaghetti. Like, this does not make sense. A bunch of white lines. You might be intimidated if you purchase a model online, or if you see one where the person just modeled, didn't unwrap, and you see it's
So what is a UV?
Oh, okay, so actually I heard from a really cool person that if you imagine an orange, just an orange in your hand, and you want to peel the orange, then take that peel and try to fit that peel that you squish down into a flat, I don't know, I guess plane in these terms. How would you fit that into a square? So imagine you're peeling. What's the best way to do it? Do you like cut 4 pieces? Do you do several of these shapes, whatever that is? Try to fit that into one square so that you see every peel and you know exactly what part of the model is actually going to have that texture, like where it is. Oh, that's so hard to describe.
Yeah, I know.
UV unwrapping is so hard to describe, but it's really just unwrapping, like if you're unwrapping.
Basically what we're trying to do is describe our 3D model on a 2D plane. We have to say where all of those polygons we made, where do they go on this map? Because this is what we're going to use to texture the object. So before we texture, we have to know, like, if I'm going to draw a big red line across this map, where does that red actually appear on the model? And so that's what this is. It's assigning a 2D coordinate to our 3D points on our model.
So before you do unwrap it, you will see this crazy mess, and if you were to paint a red line across, so many pieces of that model will have like a splotch of red here, and it won't make sense because it's not laid out just yet. Now, if you do see this and you're ready to start UVing, be sure to always have your unwrapped planes in the top right in the 0 to 1 space. This can be confusing at first because there will be 4 different sections to do it, but the top right is the way to go. So now, the robot on the right side has the unwrapped UVs. All those white lines are the models flattened out. So the top left has the bow section. The bow is actually bigger because I want that to stand out a bit. If you were to get close enough, you could see the fabric strands, so that got more space to get more detail. And the right side has the hard, and then it also has the hands and the feet. And the bottom left, the biggest area is the torso, because the torso is the larger piece on the model. So you want to make sure that your UVs are scaled to each other. So if you have something that's tiny, its UVs should be small. And if you have something larger next to that model, the UVs should be bigger because they take up more space. So on the bottom left of the slide, you'll see this weird picture. It doesn't matter what it is. But what I'm showing there is that if your scaled UVs are not correct, if you have something that's 2 things that are like this size, for example, and they have different UVs where one's huge, you'll see that the texture that is applied will be way zoomed in compared to the face next to it where everything's really small. So I hope you can see the weird pattern there, how it changes sizes. That's what you don't want to see, and you can always, while you're unwrapping and applying your textures, look at the model to make sure that the UVs are scaled correctly.
Yeah, you can also put like a checkerboard texture on your model temporarily, and what you're aiming for is that all of your checkerboards would be the same size and they wouldn't be like skewed weirdly or like odd shapes. They would all want to be squares, and that's one trick that sometimes people use when they're doing this step.
Exactly. And when you are tiling textures, that is a term that gets thrown around a lot. It's just one texture that is repeated, so if you were to scale it up and down, it would stay the same. That's used more for modular modeling and texturing. So I have an example of that here in the robot's eye. So there's 2 eyeballs in this robot. It's using one texture and one same UV layout. So if you had a town, for example, and you want to populate a whole city, you can have a brick building repeated many times using the exact same UV layout and textures. So after you have modeled and unwrapped your assets, you would then go into texturing. So I have some numbers here. 2048, that's the pixel size. So when you are creating a texture, or say you have a texture or a model that someone has given you or that you purchased, and you want to change the texture to customize it to fit your experience, and you open Photoshop or a GIMP, you can, for bigger important pieces, use a file size that is 2048. That is usually the max size people go for. It's for what are called hero pieces. So if you really want to see the detail right up close, you want a bigger file size. For smaller assets that don't need much detail, like a pen, a pencil, or an apple, it's usually best to go as low as you can, and 256 is an average low number for that. You could always go 512 for some bigger ones, and then 1024.
So one important thing to note here too is those are all power of 2 textures. That's a really important thing, and you also want to make sure that it's square. So when you're saying a 2048 map, that means 2048 by 2048. It doesn't mean 2048 by 1024.
Oh, yeah. Thank you for including that. If you had a texture that was like this and then this, that would be kind of weird.
Yeah. Unity especially is very unhappy if you don't use power of 2 textures, and if they're not square, it can get a little unhappy too.
Yeah. So I mentioned earlier that I like to use Substance Painter. Oh my gosh, it's so much fun. So on the left side, you can see the 3D model. You can rotate it around, zoom in, move your mesh around. On the right side, you'll see your UV map. So you have 2 options. You can paint directly on the model, or you can paint on the map since you know what the UVs are if you unwrapped it. So Substance Painter allows you to play with a lot of materials and bake in some metallic and roughness and normal maps and all the good stuff that I will be talking about next. So when you do a texture, it's always important to do a first pass. It's never going to be the same when you're done. So what I did here, I decided to fully go on with PBR. So that's physically based rendering, and it uses realistic lighting models and surface values that represent real materials. So plastic, metallic, organic materials, concrete, any like fabric. You can make those appear realistic using several maps. So the robot just had a steel and fabric and glass material thrown on there. And before I get further into the final design of it, I did want to go over PBR a bit more. It's becoming the standard. I don't know of a game engine that doesn't use PBR now, or any rendering engine. But here you can see that this is a really reflective heart. It's metallic, so it's full-on metallic. It's white, and the number is 1, roughness 0, so it's totally smooth, and you can see the skybox reflected. If you were to change it to be a little more rough and keep it fully metallic with an even surface, then it would look a bit more brushed. You can have a plastic look by not making it metallic, turning that to 0, and then turning up the roughness a bit more to the gray area, or 0.21. And you could always play with the numbers. It's always good to play with them and see what you like best and what works with your project. So at the end, I decided to go with this color scheme and this material. So kind of a used-up robot that kind of maybe lives in the Fallout land, because that's my favorite game. And the dark colors I chose for the feet and hands are to show that it's heavier weighted, so when it's walking around and moving, the feet kind of look like it's planning it since there's no legs. So I used color and the design of that to give it some more life and weight. And of course, the lighter colors show that they're lighter material, so the backpack isn't very heavy, and the hairbow is so light that it actually floats and it's not standing on anything. And you can see that the model itself has a bit more uneven surfaces, and it's a bit more worn out metal, and that is all done with a normal map. So you may hear that normal maps don't work in VR, and they kind of don't when you're up close, but from a distance, it actually looks pretty cool, and it helps you not have to add more edge loops and add more geometry, because that map is the magical thing that says, hey, look at all this detail that you didn't have to model.
Yeah. It's better for texture than for like big details. In games, it's been used for lots of things for lots of reasons. So for example, if I built like a window frame and I wanted like the bars of the window, you know, like traditional like crossbars, I wanted those to stand out a little bit. You could use a normal map to do that without having to add the extra geometry. That doesn't really work in VR, but if you're just using normals to add a little texture like Jazmin did here, then it totally can. So.
Yeah. That is a perfect example. You can have a window with bars with just 2 triangles.
Yeah.
So these are the results after working on the textures. I got a few maps. That's a diffuse map, or actually, I do want to talk about that a bit. Engines have different names for these file types. The color can be called diffuse, albedo, base color. Metallic can also be called specular, and roughness is also sometimes referred to as cosine. So just check with your engine what words they use and what it is, and you'll know where to apply them once you get the hang of that. So these are the maps that I use, and I have applied it to the robot in Maya here. And I duplicated it a few times because I thought it was so cute. So there it is. And now this is where Suzanne comes in.
Yes. So now we have our beautiful robot. We want her to be able to move around. And right now, like if I open up Maya, you can see I have our robot here, and I've turned the textures off temporarily, but essentially, like if I move her around, I can move her entire body, or I can try and move like a specific face, which is what Jazmin would have been doing when she was modeling stuff. But I want her to move her hands. I don't want to have to select all of these faces just to be able to move a hand around. So the process of creating a way for an object like this to move around is called rigging. So what that is building a skeleton that binds to this model, this mesh, and drives it and moves it around. So for example, let's just go and make just a very quick joint. So because generally in rigging, you want to start with the middle of the body. Let's make this a little bigger. All right, I don't know if you guys can see that.
That's good.
So that's the core joint. So that's where the rest of the body would be driven from. And then from there, I might add another joint for the head. Right here. Sorry, it's coming up really tiny. Okay, and then I might add joints for her hands, her feet, any part of the body that I want to move around, and also anytime I want to hold one piece still and have another part move. So the more joints I have, the more complicated my rig would be. But for example, like to move her antennas and have them have just the top move, for example, I might put a joint here and a joint here. And so you can see as I created these, they connected together. So that means that if I moved this joint around, it moves the entire chain of joints. But if I move this joint, the base joint, the parent joint, stays where it is. So let me open up a file that...
Cooking show style. Show you the beginning and then...
So here's what I did earlier. So you can see here now that I've got a whole bunch of joints, which is her skeleton. She's got a couple joints in her eyeballs. She's got a joint for her bow. I've got multiple joints on the hands and the feet. And then you can also see these nice lovely circles here. So the purpose of these is to actually control the joints. Because, again, we're trying to make our lives easier. So actually moving those joints around once we've bound that skeleton to it, they're inside the skeleton. So it's really irritating trying to do that. So what we do is we build controls out of NURBS curves that allow us to just decide which part moves with which. So what I might do, for example, is select, I might have already done it on this one. Yeah, so you can see like I've already parented the joints here, just these two, to this curve.
You know what that reminds me of?
What?
Kind of like my watch. If someone was to pull my watch up, my arm would raise and it would pull these joints here, but this parent would stay still.
Yeah, exactly, good example. So I would just do like, for example, I
love how the joints make it look like angry eyebrows. They're just like, hurry up and animate me already.
Yeah, so I would do like a parent constraint here. And what that means is that when this circle moves, this particular joint would move too. So let's open the next stage.
Ooh, we have like 2 ovens.
We have lots of ovens here. Okay, so I'm there with all of my joints and they're all parented now. That's where some of them are showing up pink. Maya will change like the default color of things. And you can kind of see when I select one part, which joints it's driving. So like, for example, if I select the head here, now you can see if I move that, then the whole joint system there for the head moves. So, but it's still not moving my mesh around, obviously. So the next step from here would be to select every joint, the entire joint hierarchy it's called, and also all of the mesh that I want to attach to that. So let's do that really quick. So let's select all of these joints.
That looks so creepy.
Yeah, that's our robot skeleton right there.
It's like a monster spider.
Okay, so we've selected all of that, and then let's show just the polygons. I'm holding down Shift to select all of those too, and then I can show my curves and joints again. And then I'm actually going to bind the skin. So none of these settings are super important. I set this up so that it would just bind fairly nicely, fairly quickly. But let's hit the button and see what happens. So now, hopefully, when I move this control around, you can see the mesh follows along, but it looks kind of funky, huh? Like some vertices are not moving where they should. So Maya does a pretty good job of guessing which vertices you want to be attached to which joint based on those settings. Like I set it to closest distance. So anything super close to a joint would bind to that particular joint. But it's obviously not perfect, and sometimes I might have, I might not want, for example, these joints of these vertices over here. I want to connect them to this joint, not to the hand joint. So what I can do then is I can select objects and do paint skin weights.
This takes forever, by the way. So
yeah.
If you have a model and it's looking weird and parts are stretching and you expect someone on your team to get it done fairly quickly, be ready to be disappointed because it takes a long time to get it right. It's a long process.
Yeah, so let me, in fact, open up the next scene. Okay. maybe I didn't bind this one too.
So that's a neat thing. While I am working on textures and I've given Suzanne the model, she can start then working on the skeleton. And once I have a final version that has all the textures applied, then she could go and start skinning.
Yeah, so I can build the skeleton if I have the basic model, but I definitely don't want to bind the skin until after things like UV layouts have been done. Otherwise, you get some really, really funky results. So that pipeline we showed you earlier is kind of important just in terms of like certain steps need to happen before other ones. Going back and trying to do them will just cause you about twice as much work. So let's see if it shows up this time. Yeah, there you go. So what you see here now, this is showing which joints and which vertices are driven. So this is basically anything black here is not attached to the joint that I have selected, but anything white is. So you can kind of see here on the foot, like I've selected this joint right here, and it's driving most of the foot, except there's another joint beyond it that's driving the rest. So these colors here are just kind of representative of what's called the skin weight each vertex is getting. So it's kind of just giving you a visual indicator, and I could actually go in and just paint and be like, all right, I want all of these to be driven by this. And you can see as I'm doing that, like, it doesn't really make much sense for my foot joint to be driving my torso, but if I really wanted to, I could do that. Can we see what
it looks like when you move the foot?
Yeah.
Now that it's weighted to that. Oh gosh. So you'll probably see that while you're working on some assets that have been skinned but not finished.
Yeah, so again, as Jazmin said, it's kind of a long process to go through and really properly skin a model and fix things up. I've spent days working on complicated models before to do this. There's lots of little problems here and there, and then you always end up with one vertex that's just like, no, I don't want to be driven by that joint, no, and it'll be popped up somewhere. So again, as Jazmin was saying, like if you have an artist that's taking a long time to do the rigging step, give them some more time, because this is a really, really simple rig. There are a lot of like super complicated ways to rig things. We chose a simple model and we built a simple rig for it, but this is like the bare minimum for what I could do to get a character to move around. There are so many more complicated things that I could do. So let's just reopen that.
My favorite accidents when skinning is seeing an avatar, so a human-like model smile and having the ears wiggle. So I actually have a friend who has a model where every time he talks, his ears wiggle back and forth. I think it's a lot of fun to play with.
So now, assuming we've done all of that, we get to a point where we have a model which is properly weighted to our mesh. So now we can actually move our controls around, and look, her head moves perfectly. So I don't need to actually see my joints anymore. So what I can do now is start animating her. Yes. So one of the key things to remember here is these controls are your lifesaver. They're what you want to always use to move around your mesh. You don't want to select joints, you don't want to select the mesh, you just want to select controls. And then what I can do is I can actually, let's just lock her model. So we're going to create a new layer, assign selected objects. So I've hidden the joints because I don't want to see them at all. I don't need them now. And now when I select things, I'm not selecting the mesh. I've just locked, that mesh away. So now what I can do is just start, like actually select all of these and press S, and I've created a keyframe there. So you see this little tiny red line here? Every red line represents a keyframe, or where I've locked and said this position of this object is this at this time. So that's how you animate. You decide, okay, so now maybe I want to move her hand. So I've moved my timeline down a little bit. I can move the hand up. I can rotate it around. Bring it out a little bit. I've hit S again. I've got a new keyframe. So what Maya does for me then is say, okay, well, I know you're here at this point in time, and I know you're here at this point in time, so I'm going to interpolate between those two. So it's actually doing kind of a smooth curve between them. And then say I want to move on a little further, and then maybe like twist her hand a little bit so it's like she's waving. And again, right here. So then you can see I've waved a little bit.
That is so cute. It's alive.
So that's actually what animation means. Animation means to bring something to life. So as soon as you start moving an object around, it becomes not a model anymore, and you can actually add a lot of character pretty simply. But right now, she still looks a little bit dead because only her hand is moving. So what I might want to do is like maybe move the body a little bit, and then move the feet a little bit. I'm going to remember to make a keyframe every time I do that. So, oh, I forgot to key the body, that's why. That didn't move. So stuff always goes wrong when you're doing this stuff too. You'll forget something, you'll screw up. Rigging especially is notorious for needing lots and lots of save files because sometimes you can't undo something and it breaks everything you've done for the last 3 hours. So save often, no matter what you're doing.
Yes.
And save multiple versions of files. Don't just keep saving over the same file. You want to be able to go back in time if you need to.
Sometimes these files can get corrupt as well, so if you've been saving over the exact same one and you can't open it, then you are in a really rough place. So you will see if you have artist friends and you're looking at their files, see what version they're on. You may even see robot version 50. I think I did about 12. It's really simple, but it's really helpful when things break and you can't open your file anymore and you don't know binary and you can't fix it. It's good to go back one. Oh my gosh, look at that. Isn't it so cool? So when people create VR environments and they ask me, what's the next thing that I can do to make it even better? I always say animate. When things are static, like they can look pretty, they can be cool, but having animated objects, whether it's robots or even a piece of grass that's like, ooh, there's wind here, it makes everything look so much better and more real.
So even subtle motions can add a lot of life to a character. You don't need like huge motions all the time. You, one of the core things you do when animating is actually move everything. But just move it very small amount because things that don't move at all seem kind of dead. So if you look at this model right now, so I have her body moving, but the one hand is kind of dead because it's just sitting there. It's not doing much. It's just following along with the body. So maybe then, because that hand is a little dead, I don't really want to move it a whole bunch because I want her main gesture to be waving, but maybe I just want to move it a little bit. And now it's a little bit more lively, so you can kind of see. So right now I'm just scrubbing along the timeline to see the motion. If I want to see like what it looks like in terms of time, I can just hit play over here. And it's a little bit fast, so let's select all the keys here and let's just stretch that out a little bit. So I can actually just stretch the timeline, and what that's going to do is it keeps everything proportional, but it's just slowing down my animation slightly. And we always want to snap because what happens when you do that is sometimes you might end up with a keyframe that's not quite on a frame. And so the interpreter has no idea what to do with that. Like if there's a keyframe that's like 1.5 frames, what does 1.5 frames mean at 30 frames a second? Does it mean 1 frame or does it mean 2 frame? So just snap will just revert everything to the closest frame. So now it's slowed down a little bit, so she's a little bit. Yeah, that's a little better.
I love that. That looks just like someone who said, good luck at your talk right before leaving the expo floor.
So right now she's doing kind of a snap of her head a little bit. I think it's a little bit too snappy. So one of the things I can do is actually show up here. And what I can do is actually look at the animation curve. So as I said before, Maya's kind of going, okay, I'm starting here, and then I'm ending over here, and it's guessing what I want to do in between that time portion. So what it's doing is it's doing kind of a curve where it goes, okay, well, if I'm doing those things, then maybe I want to move like this. It's not going straight from A to B, and it also kind of does like a little bit of an ease to move it, and then accelerate, and then slow down again. So I can actually look at those curves and edit them. So say I want to look at the rotation curves here. So you can kind of see I've got an X, Y, and Z. So X is red, Y is green, and Z is blue. sorry, they're not, oh, they're fairly visible up there. So what I could do is, you can see if I actually move these curves around. Let's see. You should see that she actually moves too, because I'm controlling all that entire axis of motion. So if I do something crazy like this, you'll see when I play it, it's gonna look really funky.
She's broken.
Yeah.
Gotta fix it.
Yes, I'll fix her, don't worry.
So these are the types of things that happen as well. Gotta always look at your curves and make sure it's exactly what you want. And it's really nice that you have these tools to be able to say where they should go and how far they should move. And another random tip for folks watching later in the future, if you hire someone to do something like this for you and you can afford to give them a second monitor, please do it. There's so many menus in these modeling software and animation software.
Yeah.
If you have a second monitor, that will save your life, because then you can look at the model here and then all the curves here.
Yeah.
Or
like right now, if I might have to zoom all the way in on her face, it'd be like.
And that could be hard too. So there's a lot of things that you should think about when working with teams that have artists and animators.
So I'm not going to teach you everything there is to know about animation in one day, because that's a little bit on the impossible side. But I do recommend, back in the day when Disney was doing a whole bunch of research, this group called the 9 Old Men, they came up with these 12 core principles of animation. And those are super important and super great to read and grasp and think about all of the time. So the 12 principles of animation are really what every animator should know, and every animator that works in the industry today is still thinking about and working on. All to do with things like, how things should move in space, how to anticipate motion, how to make something seem real and believable and alive. So we have a few minutes left. So the final step, now we have a model. Let me just open up a slightly different version. All right, so say she should be ready to export here. So this is a slightly different animation.
I love it.
But now I have this model, I have this animation, and I want to get it into a game engine. So the first step I need to do is I want to show my joints again. I do need them again now. Because my lovely rig that I made with all my control curves is not going to come with me into my game engine. I don't actually want anybody to ever see that. If I was just rendering this out as an animation from Maya, then that's fine. And I could totally do that. But those are things that I don't need anymore. What I do need is that animation data to come along with me. So you now see all of these like red lines here. So all of those are keys. So what I did was I selected the entire skeleton. And then I actually baked the animation. So I can do keys, bake simulation, and that's actually going to go through and do it again. And what it did was it baked all of those joint rotations and movements that I'd been driving with my rig onto the actual skeleton. So now I have a skeleton attached to a mesh, but I also have the animation attached to that skeleton. So now once I have all of that, I hide my joints again and select all my polygons. And so now I have both things selected. I have my joint selected, I have my mesh selected. I'm going to go File, Export Selection. Let's think about it for a second. And we're going to export as FBX. Right now, that's the best file format for moving between different applications if you have texture data and animation data that you want to take together. So it has a lot of options to set up, but essentially I want to take my smooth mesh with me. I want to make sure I take my animation. I'm going to make sure to bake the animation for the entire time range that I used. I want my deformed models, I want my skins. We didn't talk about blend shapes today. Blend shapes are another way to move vertices around, but they don't work super well in game engines, so I skipped over building a rig with blend shapes. And then I also want to make sure that, let's see, what else am I missing? Oh yeah, embed media. So embed media means that all those lovely textures that Jazmin did are going to come along with my model too. Otherwise, I would take this into a game engine and then I'd be missing some stuff.
And that happens too. So if you have a model, you put it in your engine, and you see that you have the model, you have the animation, but you don't see any of the colors, it might just be that embed media wasn't checked. There's also extra data that you could be including that you don't need. So cameras and lights, for example, you could uncheck those if you don't need that.
Yeah, I don't need cameras, and I didn't put any lights in there, so.
And there's way more in there that you could explore later on. But usually the defaults are pretty good. Just make sure you check what you need and uncheck what you don't.
Yes, so we wanted our animation, we wanted our media, we export selection, and we can ignore these warnings. They're just kind of saying like, you have some animation stuff, so we did some stuff. They're not going to affect what happens in your final export. In my experience anyway, I've never had any issues with these particular warnings showing up.
Only bad ones will be red, and they'll tell you exactly what's going on. Maybe you'll get an error code, and you can look that up too.
Yes. So now we are all done.
Yeah.
We've literally gone from start to finish in our asset pipeline. So
robots.
Yeah, so we rigged, we built controls, we bound the skin and painted the skin weights. We animated and we only keyed the controls. We exported. So we baked the simulation to bake those keys on there, exported as FBX, marked the checkbox, and import it into any package you want now. So whether it's high fidelity or Unity or Unreal or basically anything out there, it's going to accept an FBX file. So with that, we have 4 minutes left. If anybody have any questions for us.
Oh, we see hands.
Yeah, let's start over there.
So I have a question for textures that animate, like say checkers or how would you
To animate textures, you can actually build a rig to do that, or you can do it inside your game engine. So I could do it inside Maya, and it's slightly more complicated to do it, but essentially I would set up, you can do almost anything. You can create controls to drive and change almost anything in Maya. So I could build a rig that would do that and give me like a slider that I could move, and then I could key that slider to animate the textures. You can do a similar thing inside a game engine too. So if I was wanting to use it in VR, I would do it in the game engine and not in Maya, because that probably wouldn't come across in the FBX, or it would be just more of a pain in the ass than you really wanted to deal with, to be honest. So it's a little bit of a complicated question, but it's possible to do either way. Yeah.
Hi. Okay. Have you experimented lately with automated character generators like Mixamo Fuse? I saw it some time ago, and if you have, what are your thoughts? How do they work with VR, for example, to import one of those characters to high fidelity?
Mm-hmm. Oh, I could talk to that.
Yeah.
In high fidelity, since it is a social VR platform, you are an avatar, and others that you see are avatars. And actually, lots of people that go in there have created their avatars with Mixamo. So they'll use Adobe Fuse, create an avatar, and then rig it using Fuse. And it works well in VR because you have more joints there. And back again to high fidelity, we support the IK. So if you have controllers and you're in VR, you lift your hand and say, hello, do you want to do a high five? All of that is red and it works and it comes across very well. And earlier we did skip over blend shapes, but blend shapes are really important when it comes to facial movement. So if you do have an avatar that you got rigged online, it may not come with blend shapes and you would have to spend more time to focus on that. So if you want to smile or have your eyebrows raised when you speak even louder, you would spend more time to do that yourself before importing it. But Mixamo and Fuse are actually super helpful when it comes to VR projects if you don't have much time to make your own character.
Yeah. And the more complicated your character becomes, the harder it is. Obviously, like humans are the most complicated kind of character you can build, pretty much. Mm-hmm. So yeah, those tools are super useful. Okay. Next question.
I had a question on like when you would use something like an IK solution versus when you would animate everything by hand versus when you'd use mocap data, and like what are the right use cases for each of those things?
It depends on the project, but it also depends somewhat on the joints. So I didn't build an IK system here because I was building the fastest, quickest rig possible. But like, for example, in a humanoid rig, I would always put IKs on the legs and usually on the arms too, but maybe not necessarily in other places. because I don't necessarily want the head to drive the whole body, for example. So I wouldn't put like a spine IK, where I might want, for those of you that don't know, IK basically is inverse kinematics. So what that means is instead of just rotating one specific joint, which is forward kinematics, I could just drag a hand around and the rest of my arm would follow. So there's different cases where you would use that. Motion capture, there are good reasons to use it, but sometimes it's actually more labor intensive to clean up mocap data than it is to just animate by hand. So a lot depends kind of on the style of what you're doing and the nature of your project. Anybody else?
It was a great talk demonstration.
Thanks.
Thank you.
So early on you mentioned Oculus Medium, and how do you see, you talked about creating for VR, but what about using VR to create? How do you see that potentially disrupting the workflow and the pipeline you talked about? Because in a lot of points during your pipeline, you talked about a lot of different pain points. UV mapping is a pain point, rigging is a pain point. So how do you see actually taking that creation process into VR and how that might disrupt that in the future?
I've met several folks in VR that I've never met in real life, and I know that they don't have a 3D modeling background or even a background in art or creating content that is 3D, but with Medium and Tilt Brush as well, I forgot to add that in the slide, but these tools allow you to export what you create. And I've seen these people go from being interested in VR and being enthusiasts and not creating content to now, I'll use one person, I can't remember her name, but it's like Chaos Princess, I think. She painted this beautiful dress in Tilt Brush. So she, I think, grabbed maybe like a Mixam avatar or whatever avatar she was using, brought that model into Tilt Brush, painted on top this dress in whatever style she liked, and it was a cool, almost like, what do you call it, like 1920s style, where there's like a lot of layers?
Like a flapper kind of dress?
Yeah, I think it was inspired by that, but a lot more sci-fi, so like lots of metal plates hanging out, just going around her cool body. And she went online and found some basic tutorials on how to get what you made with an FBX applied to another FBX that already exists, which is kind of what Suzanne did today with just combining and rigging.
Yeah.
And well, she actually didn't do the rig, but she just painted the weights. That was the important part, making sure it moves with the existing body. And I've seen people create environments. So I even saw someone just like munching on a VR cupcake, and it was so cool looking. And I asked, how'd you make that? And she said it was one of the VR applications where you create art in VR. And I think that is going to change a lot of how content is made in the future, because you'll see the scale, you'll see what it'll look like. Right now, there may be some
There aren't any good rigging solutions.
Yeah, you're going to take time to rig them or maybe change textures. But hopefully, I see in the future having that process be more automated, where it's ready to go and use in whatever app that you'd like.
Yeah, the first person to create a VR rigging thing, I think, is a genius and should get given lots of money, because rigging is really hard. It's not really something I enjoy doing. It's something I can do and I understand, but it's tedious and painful and frequently breaks and just takes a lot of time and effort that really, you're like, really, isn't there a better tool out there? I mean, there are some good automated tools. Cinema 4D is another program we didn't actually include on our slides, but they have some really solid rigging tools in there, like auto rig tools. But yeah, I would really love it if somebody built something like that.
And that makes me think of something I would like to conclude with, since we are running out of time. I don't like rigging. I mean, I can do it like you said, but it is so tedious. I met Suzanne actually at a meetup in the Bay Area, and we've seen each other at hackathons. We've never worked together, but I've seen that she has more focus on animation and rigging, where mine's modeling and texturing. So if you don't know everything, that's okay. Like if you're really good and you get practice in what you do, focus on that, make friends, and collaborate and continue working on content together, and use each other's skills to have the best thing you can, instead of just being so upset that you can't do everything.
Yeah, it's tough. The entire pipeline,
really tough.
like we made it through in an hour, but if we'd actually sat down and did those things, like that fast rig, when I actually built it, it took about 3 hours. Yeah. And that's like the minimum of me just like going, okay, what's the fastest way I can do this? What's the cheapest and easiest and simplest solution? And it still took that long just to build that. So with that, thanks.
Yeah, thank you for coming. I hope you learned some stuff, and I hope that we've helped. And I've been in situations where I've had bosses that are like, I want you to do this right now and have it done in maybe 30 minutes. 30 minutes will be okay. And I'm like, are you serious? It's going to take a week. So yeah, let's all keep that in mind and keep each other happy and positive and respect each other's skills and embrace them.
Thank you so much for coming.
Thanks.